In this lecture, we will see how to remove unwanted frequencies. If you have no idea about audio frequencies, it may seem a very technical term. Trust me, it is a very easy to understand concept. Understanding the basics of audio frequencies can help to get a clean audio. I will first briefly discuss what audio frequency is, then I will show you how to remove unwanted frequencies. What is sound actually? In simple terms, the sound is a vibration of particles. These vibrations travel through the air and reach our eardrum. Our brain assigns a sound based on those vibrations. Audio frequency is the number of vibrations per second. If something vibrates once per second, we say its frequency is 1 Hz. If something vibrates 100 times per second, we say its frequency is 100 Hz. If you think of a guitar, the sound we hear is actually a vibration of the strings. The string has different vibration rates, so different strings make different sounds. A string does not generate only one particular frequency. That would be very boring to hear. When a string vibrates, it generates a combination of frequencies. It is a very vast topic, how this combination sounds different. For us, it would be enough to know that when we hear a sound, it is a combination of frequencies. The lowest frequency in any combination is called the fundamental frequency. Just like guitar strings, our vocal cord vibrates when we talk. So the frequencies of our voice sound are generated from the vibration of our vocal cords. To pronounce different words, the vocal cord vibrates differently. In other words, different sounds from our mouths have different frequency combinations. This frequency combination can be checked through Audacity. Select any part in the audio and go to Analyze. The plot spectrum will show the frequency distribution. The purpose of this graph is mainly educational or informational. You will learn which frequency has how much energy for your selected part of the audio. The x-axis shows the frequency distribution. The y-axis shows how much energy a particular frequency has. You can see in some frequencies the energy is higher, and for some frequencies the energy is lower. So what is the benefit of learning this? Well, knowing all this may not improve your audio directly, but this knowledge helps in efficient audio editing. Because there is an effect called EQ or equalization, which is very popular among audio engineers. You will see lots of videos on YouTube where people are sharing EQ tips and tricks. You may get the wrong idea that your sound is not becoming as good as theirs because of the EQ. That is not the case. So knowing these things a bit will help you identify which information is helpful for you. The purpose of EQ is to add some improvements to your audio. This improvement is not much, but it helps. In this video, we will see a basic improvement the EQ can do. If you check the frequency distribution of the silent parts of your audio, you will see something in the graph. When you are not talking, all you have is the noise. So this is the frequency distribution of the noise. The frequency distribution of noise and your spoken words are not exclusive. It means both the noise and the spoken words have some energy in the same frequency range. But if you can find some frequency area where you have no voice, you can cut down those frequencies. We have to use EQ or equalization effect to achieve that. Select everything inside the track and go to Effect. There are several effects to perform the EQ, and you will see those in the EQ and filters. I will choose Filter Curve EQ as it is more popular. It also lets you draw the EQ, so it is quite convenient to use. The drawing you see on the screen is a previously used EQ. I'll reset the graph from the flatten button. EQ is the process of manipulating audio loudness by frequencies. That means you can either increase or decrease the volume of some frequencies. The frequencies are shown at the bottom. It starts at 20 Hz and ends at 20,000 Hz. In theory, it is the frequency range of human hearing. Practically, our hearing range is less than that. As we age, we lost the ability to hear frequency at both ends. Most adults lose the ability to hear more than 16 kHz sounds. In the vertical axis, you can set the boost or cut amount. If you drag the line to the region above 0 dB, a boost will happen. If you take it below 0, a cut will happen. Currently, I drag the whole line, so it will apply a 6 dB boost on all the frequencies. In other words, it adds a gain of 6 dB to my audio. But we do not use EQ to add an overall gain. We use it for some frequencies. I will flatten the line. Audacity has some presets to get you started on EQ. You can see those presets from the factory presets. For this lecture, we are interested in 100 Hz rumble and low roll-up for a speech. Let's check the 100 Hz rumble first. It starts cutting the frequencies around 150 Hz and down. You can see some dots on the line. You can drag those dots to redraw or adjust the line. It can be dragged the way you need. You can click anywhere in the line and new dot will appear. If you drag, it will change the line from the adjacent dots. You should try adding some dots and dragging those dots to see how the line changes. I am not going to apply this graph. This is not much useful as I arbitrarily change to show how it works. I will actually use low roll-up for speech. Low roll-up for speech is similar to 100 Hz rumble, but it starts cutting down from 100 Hz. There is a reason behind this. The human voice has a fundamental frequency of 80 Hz or more. It is different for male and female. Different people have different fundamental frequencies, but it is not less than 80 Hz. So if we cut frequencies from 80 Hz and down, it will not affect our spoken words. It may help to reduce the low frequency noise. 80 Hz is a safe option to cut from, but if you have a voice recording that has a higher fundamental frequency, you can start cutting just before that frequency. That is a more advanced topic of EQ. I'll keep this video simple and cut down frequencies below 80 Hz. You can adjust the cut by dragging the line. I'll follow something like for now. There are some advanced EQ that can make the voice sound a bit better or different. I'll discuss those in a later lecture. For now, I want to learn the basics so that you can apply advanced concept correctly later. I will apply this EQ. The EQ is applied, and if I plot the spectrum on the silent part, I can see the current frequency distribution. If I compare it with the graph before the EQ, it is a bit different. I can now listen to it to make sure it is okay. Audacity is a pretty good software for voiceover recording and editing. If you can get good recording, noise-free recording, then Audacity may be the only software. It is okay, and I touched the basics of EQ. It is an important part of making the sound better. The position of the EQ also matters in the effect chain. It is one of the earlier effects to apply. Otherwise, later effects may not give the best result. I'll discuss those on the due time. But for now, you should practice what you saw in this video. You should try out various presets from the factory presets and have some idea how EQ changes the voice. The key takeaway of this video is to apply a cut below 80 Hz in your voice recording. Why you should do that and how to do that has been explained in this video. If you do not understand the concept, I'll advise you to revise this video again. If you have any questions, please send me a message.